All right, so we're gonna do Wednesday for this, and this is gonna be on reflection and then rotation, correct?
Yeah.
What page is this? This is page 9. Are we starting with page 8? Yeah, we are. All right, go ahead and read number 20.
Um, your logo for the bank for a bank. The left half of the logo shown you will complete the logo by reflecting this figure across the y-axis. Visualize in your mind what this logo should look like. Use a table to list the verticals of the left
Okay.
half.
All right, so when you look at this right here, the y-axis is this one right here, so you know it's gonna be reflected over, right? Starting at this point right here, do you see how there's 3 right there? It's gonna go 1, 2, 3 over here. That's the next point, correct? So here it's at 0, 4. That's the first one. It's still the right half is still 0, 4. It's literally at the same point, correct? Your next point over here in the blue, what is that?
That's -3 and 2.
Negative 3, 2. So when you reflect it over here, it's gonna be a positive 3 and 2, correct?
Yeah.
Next point right here, what is that?
-2, 0.
Negative 2, 0. So when it's gonna reflect, it's still gonna be 2 here. What is that gonna be?
2 and 0.
Yeah. Your next point on the left side is this point right there. What is that?
-3, -2.
And when you reflect it over, what is that
Um,
gonna be?
no, it's -3 and -3.
Okay, so that's gonna be a negative 3 and a positive 3 and negative 3,
Yeah.
right?
Yeah.
And then, of course, you go back over here to that point. And what is that point?
0, -2.
0, negative 2. And then when it goes back to this point right here, what is that going to be? 0, negative 2.
Yeah.
Okay, so then when you compare the left side with the right side, what actually changes? Which value changes?
The y value.
No.
The x values.
The x value. So when something is reflected over the y-axis, I want you to write this down. When it's reflected over the y-axis, change x value. Does that make sense?
Yeah.
So then the right half, the left half is x negative y. What is the equation for the right half?
Negative x and y.
Yeah, and then you just connect this like that. Did you connect and color it? Okay, great. All right, number 21.
As the first step in designing the logo, you draw the figure shown in the first quadrant of the coordinate plane. Then you reflect the figure across the x-axis. You complete the design by reflecting the original figure and its image across the y-axis.
Okay. You're showing the first quadrant. As the first step in designing a logo, you draw the figure in the first quadrant of the coordinate plane, then reflect the across the x-axis. You complete the design by reflecting the original figure across the y. So we're going to do 2 different transformations, right?
Yeah.
So the original x, y, this is your figure, correct?
Yeah.
Let's label the points. So I'm going to start with this point right here, this point, this point, this point, this point. Did you write it down? Let's start with that point, original points. So what's the original point? 0, 3, and then it is 2, 4, 4, 3,
yeah.
and then 4, 1, and then 2, 0, correct? First you're gonna do, so watch this, you're gonna reflect over the x-axis, correct?
Yeah.
So if you're gonna reflect over the x-axis, what do you think is gonna change?
The y.
Triangle means change the y value, right?
Yeah.
So I know that xy is gonna be x negative y. Does that make sense?
Yeah.
Okay, so then without even reflecting it, can I just say, okay, well, 0, negative 3 is the next point, correct? 2, negative 4, 4, negative 3, 4, negative 1, 2, well, 0, positive 0 is negative, exactly the same, right? But let's go ahead and actually reflect it. So here's your x axis, correct? My new set of points should be here, 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 I think here. Let's see. Yeah, here. And then here. 1, 2, no, that's wrong. Here. And then just connect the dots. So if you want to do A, you want to label it as A, B, C, D, E. That's your pre-image, correct?
Yeah.
Your image is A prime, B prime, C prime, D prime, E prime. Do you see that?
Yeah.
Okay. Then we are going to reflect the original on the y-axis. Right?
Yeah.
So the original, the keyword here is original. Original, right here. Yes?
Yeah.
The original is these set of points. Do you see that?
Yeah.
So if I reflect these set of points on the y-axis, what changes on the y-axis? Which value?
X.
Becomes a negative x, same y, correct?
Yeah.
So we're going to be using this set of points, but we're just going to change the x. So that's going to be 0, 3, correct?
Yeah.
Negative 2, 4, negative 4, 3, negative 4, 1, negative 2, 0. Does that make sense?
Yes.
Okay. So go ahead and do that.
Peppermint.
He is so good, and it's so hotel.
Did they?
They're like $1 a piece. You know that?
No.
You did or did you not know that?
No.
You didn't know that was $1 a piece?
No.
Okay. Yeah, I think for fundamental, I think like their stuff is better, their food is better too. Quality of their food is better.
Yeah.
But I still like the high end. The high end is really good too.
It's located a lot better.
What?
It's located much more the central part. It's a much more central location.
Well, it depends where you're going. Like I feel like San Francisco, depending on where you're planning on going, certain places are at a good location. Like if you want to go to Union Square, then yeah, Intercontinental, or you're going to Park. But if you want to go to like Embarcadero, the pier, well, depending on what part of the pier, then you probably want to do like higher Regency,
Yeah. Um, Or the other side.
I don't care. Go ahead.
I can eat two.
You can eat whatever you want. I don't care. Go ahead. Tomorrow you're gonna go to the gym, so you're gonna work it out. Yes.
Yes.
Yeah.
Okay.
Oh shit! I forgot to pause this. Oh. All right. Let's move on to the next one. All right. So next, you're gonna reflect. This is the next one. Reflect the first reflection on the y. So the way they worded this is really stupid. It's just say reflect the image that was reflected on the x-axis, which I'm assuming is that one, right? Because that's the first reflection, is we did the original and we reflected on the x-axis, correct?
Yeah.
So that is this set right here, correct?
Yeah.
So we want to reflect that over the y-axis. So here's your y-axis, correct?
Yeah.
So now I'm going to use this set of coordinates. But when you reflect it over the y-axis, what changes?
The x value.
Change the x value.
So
But then you're going to be using it with this set of coordinate, not the blue one, not the purple one, but the red one. Do you see that?
Negative x and negative.
So then here will be negative x, y, correct?
Okay.
So 0, negative 3, negative 2, negative 4, negative 4, negative 3, negative 4, negative 1, negative 2, 0, correct?
Mm-hmm.
So then let's just make sure we reflect it over anyways, just so we can see it. So then that's 2, 3, or actually, it's right here. This will stay here. Are they tired? There we go. Does that make sense?
Yeah.
Okay, good. So catch up.
Across the y-axis in quadrant IV, when point P is reflected across the line y equals x, its position does not change. What can you say about the coordinates of point P?
Okay, so let's first draw. Now label the quadrants. And then when it's reflected on the y-axis, so draw the y-axis, okay? When it's reflected over the y-axis, the image lies in quadrant 4, correct? So if it lands over here after the reflection, where does it start off with?
Go this way.
Where is he supposed to throw that away? Outside?
Outside.
The door.
It does not fit in there. Just go past it outside.
Go, honey, here. Okay, so where does it start then? It ends here. So where does it have to start to reflect over the y-axis and end in quadrant 4? What quadrant does it start with? This is 1, correct? If it reflects over the y-axis, what quadrant would it be? So let's try that again. So what quadrant does it need to be to end up in quadrant 4? Okay, here's 2, correct? Now reflect it over the y-axis. What quadrant does it end in? No! This is what you're reflecting over. You're reflecting over this pink line, correct? So you flip it over the pink line. So when you flip it over the pink line, where does it end? Quadrant 1. Do you see that? I don't want it to end in quadrant 1. I want it to end in quadrant 4. So before you flip it over the y-axis, which quadrant does your point start in? Knock it off. Okay, draw it. Draw in a 1. We just did this again. Now flip it over the y-axis. Where does it end in? Okay, do I want it to end in 2? Where do I want to end it in? Okay, so try again. There you go. Correct? Because then it ends in 4. So this is P right here. But then it gives you another clue. When point P is reflected, read it please.
When point P is reflected across the line y equals x, its position does not change.
When y equals x, correct? The line. This is a line, y equals x. Well, if y equals x, then your point is exactly the same, correct? Its position does not change. Well, why doesn't it change? Because it's y equals x, correct? What can you say about the coordinate of point P? You can say that this point right here is a negative x and a negative y, is what you can say. Does that make sense? That's what you can say. Coordinate of P is a negative x, which is true because in quadrant 3, it's a negative x and a negative y, right? Okay, that's what you can say. But the first part on the reflection is a bit more complicated. Okay, go ahead and read that, please.
Rotation turns all the points of the plane around the point called the center of rotation. The angle of rotation tells you the number of degrees through which points rotate around the center of rotation. The figure shows a 120-degree counterclockwise rotation around point P. When no direction is specified, you can assume the rotation is in the counterclockwise direction. While rotations can be any angle, or any degree and around any point, we will focus on the rotations about the origin, particularly rotations of 90 degrees, 180 degrees, and 270 degrees counterclockwise at the origin. For each rotation below, focus on the previous degrees A, B, C, and D when they're in degrees.
Okay, the top right there. All right, so rotation is harder because you need to have, okay, when you rotate something, before you just go, oh, I'm just rotate at 90 degrees, you have to rotate around a point called the center of rotation. Okay, so you need to highlight that. Go get your highlighter. Because me showing you how to do this, it makes more sense if you actually mentally understand what it is you're doing. And another thing, angle of rotation, okay? The point, the center of rotation, the point is this point P. Do you see that? The angle of rotation is this angle right there, and it's 120 degrees. Do you see that? Okay, now, make sure you have some color pencils. From this point right here, the distance between A to A prime is the same. Is the same distance to P. Do you understand? The distance between B to B prime is equal to the distance P, okay? So let me show you. What I mean by that is the first part right here, A to A, from this point, A, to the point P, from P to A prime. Do you see how it's exactly the same distance? Okay, next one, B. The distance from B to P is going to be the same distance from P to B prime. Do you see that? Same thing here. The distance from C to P and then from P to C prime are going to be the same. Okay, now look here. C to P is this green line, correct? P to C prime. Do you see how the distance is exactly the same? Do you see that? That is essentially how you create that 120-degree rotation. So you do need to have a protractor. Did he give you a protractor?
No.
Okay. We might not need it. I don't know. Maybe. Do you see a protractor over there? All right. So, rotation 90 degrees about the origin. Where is the origin located?
Let's read.
The origin is located.
Origin 0, 0, correct? Remember how we talked about the center of rotation, that point? The origin is your point of rotation. Do you see that? So we're going to put a point right there, correct? All right, so if I start with D, because do you see how D is the closest point to the origin? You draw this line, okay? That looks about maybe 1 inch, right? So when I rotate that line to 90 degrees and I redraw the D prime, remember, D to 0, 0, which is that point of, pay attention, rotation, right, is going to be the same as 0, 0 to D prime. Do you understand? So with your protractor, you put it right. Oh. You put it right here, correct? If I put it right there, you see that center right there? 90 degrees is right there, correct? So you're going to draw a line like this, okay? So you can't see that, but I just want to show that to you. So about the origin. So 90 degrees will be right here. So this is like 90 degrees right there, correct? This is 90 degrees, correct? Yeah. But I'm not going to go ahead and just use up that entire line. I mean, I won't put my D right there because then that length is too long. Do you see that? You only want this much of that length, right? Which technically should be right there. Do you agree with that? Yes. So this part right here is a D prime. And do you see how this blue line to the origin is exactly equal distance? Do you see that? Then you're going to do the same thing with the other points. E. Do you see E? Yeah. To the origin. E prime. Is that still at a 90-degree angle? Yes. Yes. So I want you to do that to all of them, please. Draw the line. Show me the equal length. But with different colors. Do the same thing over here. So A is the furthest one. Well, actually, let's do B. B is the furthest one, right? When I draw B, use a straight line here. This is probably like 2 inches, correct? If I do 90-degree angle from here, do you see right here? It's still 90 degrees right here in the purple right angle. But B prime is about 2 inches from the origin. Do you see that though? Are you getting that? Okay, let's try another one. Let's say, for example, C. Do you see C right here? C to the origin is about 1.5 inches, right? To make a 90-degree angle, it's going to be right over here. Now, with the green line, do you see the right angle that I'm creating right here? Do you see that? Yes. This is still about 1.5 inches. Do you see how the rotation works now? I want you to draw those lines, okay? So you see it, correct? So then X, Y, predict A prime. So A, what's the location of A right here?
It's.
Look at your paper. Okay, tell me what is A? -3.
Oh, -3 and 9.
Okay, A prime. Look at A prime. I told you to use different colors. What part of that did you not freaking understand? What is A prime? What is the corner of A prime? Don't tell me that you're getting frustrated because you don't understand that. Well, I don't understand when I ask you to use different colors, literally have different colors. What part of that did you not freaking understand? So I'm a little bit less sympathetic when you tell me you don't understand something. Do you understand that? What is A prime? What changed?
The X value or Y value. So.
I don't know what that means. You need to tell me specifically. How did you get from here to here? What switched? What changed?
Both the X and Y value.
Switch what?
X and Y value.
You do not touch the black laptop without my permission. You understand me? What's the X and Y value? So if it's X and Y like this, with the rotation, it becomes Y comma X, correct? What else changed?
the y value the one value is negative.
That's it. So predict A prime. A prime was -9, comma, -3, correct? What was your equation? Xy then becomes a -y, comma, x, correct? If you had to use that formula, predict B prime, what's B prime? So let's start with B. What is B again?
B is 7,
Positive or negative?
negative 7 and 9.
Okay, so then if I use the rotation formula, what would B prime be?
-9 and -7.
Do you see how that works? Now check, is B prime at -9, -7?
Yes.
Good. If you have that formula, are you able to use that formula for any of the points without actually drawing it? You need to memorize that. 90-degree rotation, switch the X and Y, put a negative on the Y. Do you see that? Okay. 180-degree rotation. Now we're completely something different, okay? About the origin. So once again, go get some color pencils, please. And I want you to try this on your own. All right, so here's your origin, correct? So D, now remember, the distance between D to the origin is going to be equal from the origin to D prime, correct? With 100-degree rotation, right? 180 degrees is like this much, correct? So there's that, right? Well, if it's a 90-degree rotation, you know if this is here to here, then I have to draw that point to here. Like that, correct?
Yes.
If it's 180, it's from here to here. To make it 180, it just goes straight like that. Does that make sense? So it will make sense that this point right here, or no, that's wrong. Not that point. That point has to be a D prime. Do you see that? So then let's write down the points. D is, what's the location of D? Negative.
-3 and -3 and -2.
Good. -3 and +2, correct? What's D prime?
Wait, negative.
It's -3. D is at -3. It's right here. Isn't that D? What's D prime?
Sorry, 3 and -2.
So compare. What changed? The position didn't switch in like 90 degrees where Y becomes X, X becomes Y, correct? What changed?
The X value became positive and the Y value became negative. That's just flip both negatives.
Right. So if you have to write the equation, XY becomes what? What's the equation for the 90 or 180-degree change?
X and -1.
There'll be a negative X
Oh,
and a negative Y. The negative means it becomes the opposite. Does that make sense? If you could try it. -3, negative X. What's a negative -3? What's a negative +2? Does that match?
yes.
Then that's the equation. Does that make sense? All right, so then this right here shows 180 degrees, correct? Now, if I were to predict A, let's do original A first. What's the corner for original A?
-3 and 9.
Good. Now, using this formula right here, will be A prime.
It would be +3 and -9.
You got it. Now, what's B coordinate?
B coordinate. Where is it? -7 and 9.
Okay, so if the change, what would it be?
7 and -9.
There you go. Did you get it now?
Yes.
Okay, let's go on to the next one. Now we're gonna do 270-degree rotation, but it's exactly the same steps. I'm gonna have you do it on your own, okay?
Yes.
All right, so 270 degrees is a little bit more, right? So with this one, I don't think I'm gonna draw that from the origin anymore, mainly because it's gonna look really kind of weird. So let's just start with A. So what is your point A here?
-3 and 9.
-3 and 9. And what's your A prime?
9 and 3.
9 and 3?
Yes.
Okay, so then what changed? How do you get from -3 to 9? What changed?
The negative in the x value was switched to a positive.
Okay, switch X and Y to Y and X, and then what else?
Positive.
Change X and -X. And that's it, correct? Well, I'm sorry. No, hold on. Change Y, correct? Right? Well, okay, if you're gonna switch, let's say this way. I will have to say you do switch first. Switch XY to YX, correct? Change sign. Which sign do you change? If you get to XY, it becomes YX, but then the X becomes a opposite sign. Do you see that?
Okay.
Opposite sign for the new Y, which is a -X. Does that make sense?
Okay.
Okay, so then your equation is going to be Y comma -X. Does that make sense?
Yeah.
That's your equation, correct? So -3, 9, if I cover the A prime and I don't see it, I use this equation, like this equation that I use right here, then -3, 9 becomes 9, +3. Is that what we have?
Yes.
Great. What is B? Original point.
-7 and 9.
So if I flip it, so be 9, and then that -7 become +7. Does that make sense?
Okay.
Great. So rotation in the coordinate planes. This is a summary, right? Great. It's a summary. This is what you need to memorize. Okay? Put a star around it.
Yeah.
When you do rotations of 90, I remember XY becomes YX, correct?
Yeah.
And the negative's on the Y. Is it negative on the Y? Is that correct? What was the equation for a 90-degree rotation? It's not on this page. Go to the other page. If you can't remember it, then make sure you know where to find it. Okay, 180-degree rotation. Was it just everything changed the opposite sign? Like -X, -Y?
Yes.
Yes, check.
Yes.
Okay, and then what was the rotation of 270?
Y and -X.
Did you write it down here?
Yeah.
Great. So then figure out the next one. Which one are you going to go over? What, number 26, 27, or 28? Which one do you think is harder?
Probably 20.
Fine, 28. 270 rotation, correct? 270 rotation, the equation is XY becomes Y, comma, -X, correct? So we're starting with this point right here, right? That point looks like it is at a -2, -2, correct? If I flip it, then it becomes a -2, +2. Do you agree? So -2, +2 is there. That's that point. I'm going to use different colors, correct? This point right here, the green, that is going to be a -1, 1. So if I flip it, a +1, +1. Do you agree with that? Okay. Red. That red point is at a -1, +4. If I rotate it, it's a 4, +1. Do you see that? Because everything here changes, right? To an opposite sign, the second number, correct? So 4, 1, 2, 3, 4, positive 1 is right there, okay? Next one, this point in blue. That point looks like it is a -4, positive 4. If I flip it, it's a positive 4, positive 4. So 1, 2, 3, 4, 1, 2, 3, 4. I feel like I fucked up somewhere. Hold on. Let me check. No, go.
For my work,
-2.
I didn't flip over the 4 and the 1 on -1 before. But I still got 3.
Okay, I don't know what that means. What are you trying to say now? Okay, no, I'm asking you, is this the equation? Is that the equation? Is that equation correct? For 270. Why -x? -2, -2, -2, +2. No, that would be correct. -2, +2. Oh no, I screwed this one up. That should be a -2, +2. -2, +2.
Oh.
That would make sense. Okay, now, once you're done with all 4 points, correct? The way you draw the picture matters, okay? Now, look over here. Do you see if I start with the blue? Do you see that? The blue line connects to the green line. So I connect that to the green line. The green line connects to the red line, or the red dot. The red dot connects to the blue dot. Do you see that? Blue dot connects to the dark blue dot connects to the light blue dot. Now, do you see how it works? Do you see that? This is your pre-image, and this is your image. It's a new image. Does that make sense? Okay. And then if I were to show you how this works on a protractor, hey, if it's at the origin, I'm going to use the light blue. Do you see that line right here? If I put that line right here, that dot has a match up. Come on, get up, stand up, please. 270. Oh shit, I don't even see 270. Forget it. Yeah, you don't need to have the fucking protractor as long as you know the equation. Does that make sense? But do you see how your picture does not match what it should be?
Yeah.
Okay, but do you understand now what the equation, this is how it works?
Yes.
Great, I want you to do 26 and 27 on your own. All right, so 90 degrees. Okay, what's the formula? X, Y then becomes, is it -y comma x? Is that the formula?
Yeah.
Okay, so start off with this blue point. That blue point right here is what?
That blue point is -3 and 1.
Okay, then that should be translated to -1 and -3, correct?
Yeah.
-1, -1, 2, 3. Okay, there we go. Next one, I'm going to do the red point. Red point. This red point is what?
The red point is -4, -3.
So if I transform it, it should be a +3, -4, correct?
Yeah.
Okay, then I'm going to do the green point, correct? That green point is at
-1 and -4.
And if I translate that over, it will be a +4, -1, correct?
Yes.
Okay, now the way you follow this is important. You're going to go from the blue line to the red line, so blue to red, red to green, green to light blue. There you go. That's a 90-degree rotation. Do you see that? Is that what you have? Good. This is getting easier. Did your teacher teach you how to do this?
Yeah, I took the notes, but I just didn't take my notebook.
No, but did he teach you how to do this though?
Yeah.
Okay. X, Y, what's the equation? Is it just -x, -y?
Yes.
Okay. All right, so let's start off with this point right here. That pink point is at 0, negative 2, correct? So that's just 0, positive 2, right? There it is. Purple point. That point is at, what is that?
That's 3 and negative 1.
So it'll be negative 3, positive 1, right?
Yes.
Then I have the blue point. That blue point is at 4, 2.
Yeah.
So it'll be negative 4 and negative 2. Negative 4, 1, 2, 3, 4. Okay. Then we have the green point, correct?
Yeah.
That green point is at 1, positive 2, right?
Yes.
So it'll be negative 1, negative 2. Okay. You got to follow the steps. Purple to blue, yes?
Yeah.
Purple to blue. Blue to green, yes?
Yeah.
Green to pink, correct?
Yeah.
Pink to purple. There it is. Do you see how that works now?
Yeah.
Okay. I'm going to have you do number 29. Did you do number 29 yet?
Yes.
You did? Okay. Read it for me, please. What do we do?
Reflect angle JKL across the x-axis, then reflect the image across the y-axis. Draw the final image of the triangle and label it JKL. Describe the signal rotation rotation on maps JKL to JKL. Prove this using coordinate notations for the point X and Y.
So what does that mean? What do I do? What's your first step?
I draw my first reflecting angle on the x-axis.
Okay, so across the x-axis, there's my triangle. So label the x-axis. You got that? All right, well, it should be pretty easy. K is going to be right there. That's K prime, correct? J, and that's 4. 1, 2, 3, 4. Correct? That's J prime, right?
Yes.
And then let's see the blue one. L is L prime, correct?
Yes.
Then we're just going to connect the dots there. Oh, come on. You stupid pen. Why is it doing that? Stop doing that. Stop. I don't know what's going on here. Okay, there we go. That's what we have, correct? Okay, what's the second step?
Then reflect the image across the y-axis.
Okay, we're going to reflect the prime, right? The image across, not the pre-image, the image. So it's also important that you label this. This is pre. This is the image, correct? Okay, so let's flip it over. So that blue is now over here, and you're going to label it L double prime. K. Wait, 1, 2, 3. 1, 2, 3. So I'm a little bit off. That right there will be K double prime.
Yeah.
And then that'll be J double prime. Correct?
Yeah.
There you go. All right, now what?
And then the last one,
Oh, we did already, correct?
Yeah.
Oh, we did it, right? We did it. All right, next one. What does it say?
Oh, describe a single location that maps JKL to JKL.
Okay, so is it 180? Is it 90? Or is it 270? Which one do you think it is? Yeah, because if we look at the pre-image, do you see how from the origin to the blue dot is right there? Then from the origin to the new blue dot, L double prime, this looks like a 90-degree angle, correct?
Yes.
But then you need to go ahead and describe that rotation. So I suggest you go back to how they describe the rotation. And what did they say? They said something like rotate 270 degrees about the origin, right? So what you can say is triangle JKL is rotated how many degrees? About the what? To create what? What's the new triangle?
JKL double.
J double prime, K double prime, L double prime. Does that make sense? Okay, now, what are you going to do for the next one? I'm going to pause and let you try that one on your own. You're going to have to use the equation like X, Y, arrow, something. Okay, so since this is a 180-degree rotation, right? What is the formula again?
X, Y turns into negative X and negative Y.
We're gonna prove that, correct?
Yes.
So let's start off with the pre-image. The pre-image, what is the blue one? That's 1, 1.
Yes.
What's the red one?
The red one, 3, 1,
And then what's the yellow one?
1, 4.
1, 4. Okay, now look at the image, right? Well, the pre-image is just JKL, correct? The new image, and the reason I'm calling the new image is because the image is J prime K prime. The new image is J double prime K double prime L double prime, correct? So 1, 1. So that's the blue, correct? If I use this formula, does it translate to negative 1, negative 1? Is that where the blue is? Yes, it is. Now 3, 3 is the red, correct? This is blue, red, yellow, correct? Is a red negative 3, negative 1? Look at the K. Yes, it is. L, which is 1, does it negative 1, negative 4? Then just state that and just say the pre-image JKL was at 1, 1, 3, 1, 1, 4. And then the new image J double prime, K double prime, L double prime is at negative 1, blah, 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 right? Which is aligned with the 180 rotation equation of x, y becomes negative x, negative y. Does that make sense?
Yeah.
That's it. All right, we're done.
Okay.
Quentin, I need you to come downstairs for your homework, please. Wait, hold on. Did you check her grades?